Okay, good afternoon. Yeah, my name is Moeketsi Mosia, as introduced from the University of the Free State. So I'm going to be sharing some of the work that we've been doing as ETDP SITA chair. So we are ETDP SITA chair is a chair that's funded by government, specifically looking at mathematics. We are sitting at the intersection of the higher education and the basic education. So we give feedback on both ends. For higher education, we might recommend certain things based on what we're seeing from our research and so on. And similarly, send feedback back to the basic education through different forums that they have as well. So that's our purpose. And we do a bit of training, particularly from this year onwards. We'll be engaging with a lot of teachers and training them. And we work in quite a number of provinces. In the 9 provinces, I think we've got presence in all except for one. Please don't ask me why that one is out. So, and we have the Western Cape region here, which is co-led by Katerina and Moses, who's here. So I'll be focusing particularly on one aspect of that kind of work, just picking some kind of a case study to some extent, just to give you a sense of what we do. So would look at, as I said, preparedness, because that gives feedback to the basic education, but similarly, it also gives back some I wouldn't say feedback, but it gives some kind of preparedness levels that the higher education should take into account. And of course, we're finding ourselves in a quite a diverse context within our country, and we need to understand how those nuances affect ways in which learning happens in mathematics. So just to give a sense of particularly some of our focus would be trying to get that gap right between schools and universities, and helping the students do that smooth transition between the two sectors. And one of the things we're confronted with is the unevenness and the levels of preparedness in the sector. And we're finding it a bit hard to get a very coherent piece of work that enables us to understand this much better. And we're trying to make contribution towards that. Some people have tried. We are only one player that makes that contribution towards that context specifically. There's a set of research questions that we care about, and one of those I'll just pick one or two, but they will come again as we go further. Is is that when Okay, maybe I should provide a bit more context to it again here. Is that in this study we got secondary data of student performance in mathematical sciences. In mathematical sciences, that would include engineering, mathematics and applied mathematics, actuarial science, mathematical statistics, all that, all even BSc in physics, as long as the student takes their mathematics 1, 2, and 3, mathematics almost a major, at least up to a second year. So we get in that data. We managed to get a whole lot of that data in 2025, and then the idea was to check in terms of performance. Are the institutions themselves able to explain variation we're seeing in the student performance as far as mathematics is concerned? So that's one point that we're looking at. And secondly, we wanted to look at the performance in the school living mathematics. Does that have any predictive power in terms of their subsequent performance in the subsequent years of whatever qualification that they enrolled in? And secondly, we wanted to control certain things. We wanted to make sure that, because universities attract different profiles of students, so we wanted to almost bring some form of equality, if you like, or equity, if you like, and look at, does that change the kind of outcomes we see if we were to get all students that are A-level kind of students and across different institutions, and compare those and only those in terms of either their agenda, their performance, and sort of control for those variables. So that's one question that we sort of cared about. So I think I'm not going to talk to all of them. They will come as we proceed in the presentation. And as I said, this is secondary data that we're dealing with. In this case, we're presenting only data for 3 universities. And of course, I'm not necessarily going to disclose those because we had said will not disclose when we applied for ethical clearance. And we largely tend to use the Bayesian framework, partly because it enables us to encode some of our beliefs about the state of the world. And the state of the world here could be other patterns of performance from different type of students. So it enables us to do that kind of work, but also it helps us to do partial pooling, which is the students come from the same population to some extent, and they live in the same country. So there is some things, characteristics that they share, and we want to take advantage of those in the modeling process. So that's one of those. And of course, we because of that, one of the known frameworks, it's a PyMC. It's a Bayesian framework in Python. In this case, we looked at about 3,854 students from these 3 universities, and they had repeated measures. So you would have their mathematics performance in first year, second year, and third year, and from all those three institutions. And then we fitted a couple of models on that data just to get a better understanding of which models performs better and so on. Now, from that, the first question, as we saw in the beginning, is that we realize that the institutions don't really have that much. They don't account for that much variability. So the fact that you're at institution 1 doesn't necessarily put you in a particular advantage position that can explain the variability. So, which is a good thing, I think, for the first, at least there's quite minimal, only accounts for about 5% or 5.5% of that, with a probability of that one that is greater than 10. So I think we're comfortable there that they obviously each institution would have some impact, but it's not that pronounced. But what we picked up is that what accounts for this variability is largely between the students themselves and also within the student themselves. So it's at least locked up in the student population. So either their own individual level of preparedness as compared to other students, as opposed to having a much more chances of succeeding because you went to university A. Yeah, so that's what we are sort of finding in response to this specific question. Secondly, around predictive validity of this, we did realize one point is that, so we almost measure in sensitivity of performance. So if I were to get one more point or one more percentage in my matric mathematics results, what will be the change in terms of performance of mathematics in the subsequent 3 years at different universities? And what we are seeing here is that at University 1, if I can just have slightly improvement in mathematics, it will become slightly bigger when I get to the University Mathematics 1, 2, and 3. While in others, the other 2s is quite minimal. So we do know now that that university has that benefit. If you were to improve slightly, you will see slight difference. So I think those are sort of feedback we give back to the sector around either admission issues for their students and so on. And then we adjusted to almost make the play field leveled, is to say, okay, fine, we also know that certain students from certain populations of society get attracted to certain institutions. And therefore, if you ignore that, you might make a very bad finding, because it's maybe as a result of the kind of students that are going there and not necessarily anything useful you are claiming to be. So that's one we're trying to do that here. And you could see here that in the previous one, it looked like University 1 was doing way better than University 2 and 3 in terms of the student performance here. But we are seeing that it looks like once you control for everything else, University 2 jumps up to become the highest. These are averages in terms of their average estimates across these this population. So again here, it's worth looking at what does University 2 do, which is different to University 1 and which is different to University 2. And again, this is where we follow up with more qualitative studies to get what kind of support the students get. We've run some of the surveys, particularly in the engineering space, where students express perhaps the difference in ways of learning, in ways of being taught. I think one of the surprising outcome was that from the qualitative data was that the student indicated that the academic stuff. So we're asking them, how is this transition from ways of learning or even teaching from high school to university? They said university staff members doesn't care. So they don't have care. They just teach and go. It's up to you whether you survive or not. It's really up to you. So I think they raised that point, which was quite an interesting one to get. So that helps us to understand, why is this changing? Why is this picture changing for certain students? So that was one of the findings that we've had, particularly for these three institutions. The other thing we cared about, and I think part of this was our big presentation at Delta, if you sat in our session, was departing from this slide, but for the whole sector, is that we picked up that students that come with an average that's a bit high, or not even an average, a mark that's high in mathematics, tend to decline a bit. And those that came low, they are quite stable in their performance. It might increase slightly, or if it goes down, it's not too bad. It's within a particular, I would say, tolerable credibility interval of some sort. So, but while others that start up, they tend to go down quite severely. So we again here are thinking that perhaps we need to have differentiated kind of support programs, because we oftentimes says this is a student that is doing extremely well. They're coming with a 90%, 95% in their final mathematics results, and therefore they don't need support. And I think we need to carefully think about those. So we are picking up that there's the groups of the students that are coming are not homogeneous. So you need to cater for those little groups, but the difficulty is forming these clusters that need support. And sometimes the difficult part, sometimes it's well, forming the clusters, but once you form the clusters, also you want to be careful that those students they doesn't create the stigma around them as well. So you need to carefully manage that process as well. So that is one issue that we are almost saying we need a support program that's not just one size fit all kind of approach. 30 million, I'll be there. So I'm almost. So again here, one of the interesting thing is that I think we still, there's also another national project, a research project. There's even a book around it, around how to close the gaps. One of those gaps, it's racial gaps, quintiles gaps, gender gaps. There's all kinds of gaps that the book project is focusing on. And we looked at these as well. We realized that there is some gap, perhaps not so bad in my own assessment, it's a subjective assessment of gender gap, for instance. For some reason, well, maybe not for some reason, because I know in my own institution, students that gets to get their degrees with distinctions are oftentimes female and not male. But I thought in mathematics it might be slightly different. But the outcome we got here was that is still the case, that we're seeing that. Again, strictly here comparing it with just quintile 1 only, while perhaps in the presentation of the few colleagues that might have been at Delta, we looked at 1, 2, 3 combined together, and quintiles here, the socioeconomic status of the schools. These learners come from 1 being the lowest and 5 being the better resourced school. We realize again there's another gap that we may need to think about it slightly more carefully. And I think when we took this sort of against what we're getting from the literature, these are sort of 5 points that we are finding ourselves, is that we need a very multi-layered approach and support to the student support or ways of learning. And again, we've realized that there are groups that, because of certain characteristics that they have, they would need a specific type of support, and that outcome in mathematics in high school does matter a lot in terms of how that student is going to proceed moving forward. Again, here we've realized that if we control for some of these characteristics, the students are able, even to some of the universities that is not performing that much as compared to others, we're beginning to see a slightly different picture. They're again showing again that there's a need for finding ways that brings some kind of equity, even if it's equity in terms of opportunity. And here is opportunity of support more than just opportunity because they are already students and registered in an existing program. Maybe I will stop here, and these are just some listed limitations of the study.